Hi guys, welcome to part 3 of this series on the retrograde motion of Mars, the project that you guys have. And we still have time. It's due in, I think, in May, but we really should get going on it. As I was saying, it really is, there's a lot of work in it. And you need to get started on it as soon as possible. So the third part, as I was talking about and before, and let me find it first. Let me make sure I have the page open. Okay, and let me share the screen. There it is. So we did the second part. The third part, actually, it's still on those pages from chapter 11. Chapter 11 and 12 are related, so please go back to them and read them. If you have any questions, you need to let me know. So now we are in the heliocentric model, namely the sun is actually the center of the solar system. And the Earth orbits the sun. And the inner planets also orbits the sun, namely Venus and Mercury. And the outer planets also orbit the sun, and that starts from Mars all the way onward. Okay, all of them experience retrograde motion. And if you follow basically the arguments in there, you should not have any difficulty with it. The point being in here is the formula. Okay, the formula is a little bit complicated to get it where you get it from, but this is the formula that you're going to be using for the next table. Okay, so we need to compute S. How do we find S? We take this number for the Earth, which is 12. So the T stands for the period, the time it takes for a planet to go once around the sun. For the Earth is 12 months. Okay. For Mercury, it's 2.89 months, that is Earth months. So it's just less than 3 months for Mercury to go once around the sun. For Venus, it's 7.38 months, just short, about 7.5 months, okay, to go once around the sun. Again, it takes less time. Obviously, the Earth takes 12 months. Mars takes 22.2 months to go around the sun. The year on Mars is longer than the year on Earth because of its slow motion compared to the Earth. Ceres, which is another dwarf planet that sits between Mars and Jupiter, takes about 55.2 months. It's a long time, okay? Jupiter takes 142 months. Remember, if I multiply 12 months by 10, that's 10 years. So this is slightly more than 10 years, actually almost 12 years. So 12 years on Jupiter equate 1 year on Earth, okay? 12 years, 12 times 12 is 144. So this is 2 months short of 12 years. So it's just a bit short of 12 years. Saturn, though, is 356 months to go once around the sun, okay? So it's extremely slow. This is the data that was given to you. You were told that on February 26, 2020, Mercury went through a retrograde motion, and also Venus on this date, June 3rd, 2020, and so on and so forth. All of these dates are from 2020, the dates when we recorded the occurrences of the retrograde motion. You need to compute this value of S and put it in this column. For each planet, you're going to change T, where T is this number. For the case of Mercury, it's 2.89. So what I do in this case, I do 12 times 2.89 divided by 12 minus 2.89. Okay. If you're using a calculator, do the two operations separately. Okay, do the 12 times 2.89 and write it on a piece of paper. Then do 12 minus 2.89 and write it on a piece of paper. Erase everything from the calculator, and then take what you wrote for the product of the two periods and divide it by the difference of the two periods. When I say the difference, I don't care about the sign. The calculator, for example, if I take Mars, and I put 12 minus 22.6, the calculator will give me a negative number. negative 10.6. I don't care about the negative sign. All I care about is the raw number. That's what this two lines mean. The two lines mean the absolute value. So the absolute value doesn't care about the sign. The sign will come from the denominator. All of these guys on the bottom will be negative. So just ignore the sign. Write S in here without any sign. So again, to repeat how you do this, you multiply 12 by this number and you write it on a piece of paper separate by itself so that you know what that product is. You take 12 and you subtract from it this number, ignore the sign of the calculator and write the number without the sign. Now you're done with the numerator and you're done with the denominator. Then at the end, you do the ratio of the product over the difference and write the number in here. Okay, that is actually a number of months, how many months that is. Okay. Now, the number of months, you have to be careful in this formula in here and convert the months into days by adding basically by multiplying those months by 30 and converting that the difference. Let's say, for example, you ended up with a value for S, and I'm going to do an example so that you guys see it. I'm going to pick up Mercury, and another planet. It doesn't matter which, okay? Then the difference in this case is going to be the number of days when I multiply it by 30. So I have to multiply by 30 to get the number of days, okay? Once I find the days, then I add them to this date. There are several ways of adding them. Either I add them manually on a piece of paper. So let's say, for example, I ended up with 17 days from this date. So I come from February 26th, 27th, 28th. I ask myself, is 2020 a leap year or not? If it is, then 29, the 1st of March, 2nd, 3rd, 4th, 5th, 6th, 7th, that's 10 days, 8th, 9th, 10, 11, 12, 13th, and the 14th. So it's going to be the 14th of March, okay? That is if it turns out to be 17 days, okay? If it's more than 17 days, you have to keep on adding until you reach the date. Then you're going to write the next occurrence in here. That is your prediction when the next occurrence will happen. And you do that for all of them. You can do the addition manually, but it's prone to make mistakes. So one way to fix it is I'm going to show you how you can use Excel to do it if you have access to Excel, or there are some online tools that you can do also that should be able to help you find the next occurrence. So this is basically in a nutshell what this part is. It's making predictions, predicting when the next occurrence is going to happen using the heliocentric model. So let me stop sharing and let me go back to the report, share the actual report. So we're doing part 2, as I was saying. Now we're predicting the next occurrences based on the heliocentric model. And we're going to answer a few of these questions about the model itself. And again, read the comments, read the chapter and go through it and make sure that you have full understanding. If you have any questions, please let me know. Then the next page is when I do the calculations. So I put an S in here. I don't know. Let's say, for example, 2.545. Then I take this number and multiply it by 30. Okay. So if I multiply it by 30, I'm sorry, then I multiply it by 30 and then add it to this number. So, and let's say, for example, it's going to be on March 14th, 2020. Okay. So this is the next occurrence, and I move forward to the next ones and so on and so forth. And then based on that, I'm going to make conclusions based on this model and the overall project conclusions. So I'm going to take the data for Mars, and I'm going to use a calculator in here to help me do these things. And I'm going to take the product as I was saying, okay? So 2.89, let me stop this sharing and let me get a calculator going. Where is my calculator? So this computer. Calculator. I'm going to take a simple calculator. Okay. So, and let me share now with you guys the calculator so that you see how I'm doing this one. So I'm going to share the calculator. So the first thing is I need to multiply 12 by 2.89. So this is 12 times 2.89. And the answer is 34.68. I need to write it down so that I can remember this number, okay? I can remember this number, and I'm going to put a pen in here. Here it is. So it's 34.68. Okay, so that's good. So this is the product, and I'm writing next to it that this is the product. I'm going to do the same thing, the difference. So I'm going to say 12, subtract from it 2.89. And the answer is 9.11. I really don't care about the sign, but the sign is positive. So at this point, it worked out fine. So this is the difference. So I'm writing in here next to me what I say, what these things mean. So the next thing is to take 34.68 and divide it by 9.11. And that is going to give me, so 34. The nice thing about this calculator is I can see the numbers in here. So I really don't need to write them, but you may not have this calculator, so you probably should write them anyway, okay? So divided by 9.11, 9.11. And the answer is 3.806 something. So 3.06, no, 3.8068, okay? I really need to do some rounding at some point, but this many sig figs is good enough. Okay, so now I found the answer. So I'm going to go back into stop sharing this. Okay, and I'm going to share with you guys the report itself. And I'm going to write the answer in here being 3.8068. Okay, so that takes care of that. So I'm going to come back and stop sharing again. And I'm going to share with you the calculator one more time. And this time, I'm going to take this number, 3.8068, and multiply it by 30. It's going to be 90 something. The reason why it's going to be 90 something is because I know 3 times 30 is 90. But don't say 0.8, so it's going to be more than 90, because this is almost close to 4. So again, 3.8068 times 30, because on average there are 30 days in a month. So again, the answer is 114 days and 2/10 of a day. Who cares about 2/10 of a day? It's close enough from 114 days. Okay, so 114 days. So I'm going to stop sharing the screen, but I need to do some other calculation now. Okay, remember the last occurrence. Oops, what is this thing in here? So the last, let me share with you the screen again. Last occurrence is February 26, 2020. So I need to add 114 days to those, okay? So I'm gonna try to get Excel in here. If you don't have Excel, don't worry about it, okay? I can let me get a new file of Excel in here. I don't want to use that. There's some stuff in here that I actually don't want to change. So let me stop sharing whatever I was sharing, and let me share with you the Excel file. Okay, so again, the date that we're talking about is February 20th. Why is it not writing? Is February 20th, 2020. If I come to that date and add to it 114 days. So it's this date, which is, that's how you write formulas, by the way, in Excel. You write the previous cell or the cell that you want to add stuff to it. And you simply add 114, okay? So if this calculator is correct, then it's telling me the next occurrence is going to be on June 13th, of the year 2020. Okay, so if you don't have Excel, don't worry. I'm going to show you other tricks also so that you can do it again manually if you like, or manually is going to be really hard, but you should be able to get the same answers too if you do it. Or you can actually get some online tools also. You just search for how to add dates from how to add days to a date, and then you should be able to find it. I'm going to send you good useful links for that. So let me go back into the report to make my final predictions for this one. So this one is going to be occurring on June 13th of the year 2020. Okay, we're done with Mercury. We should repeat the same process for other planets. So in the last recording, I'm going to be sharing with you guys other tips on how to do the same calculations, and also take another example so that we have another one to compare to. Thank you.